All right, hi you guys. Here are the answers to the Module 7 review for IM3. These first few problems are Module 7.1, and so that's when we're finding all possible rational zeros using the rational root theorem, and then we're going to find what the rational zeros are for these. Remember, we can think of zeros, roots, and factors all as the same thing, it's just they're written in different forms. Okay, so for the first one, remember, if I want all the possible rational zeros or roots, I'm going to take all the factors of my constant, so plus or minus 1, and I'm going to divide by all the possible factors of 4. So plus or minus 1, plus or minus 2, and plus or minus 4. Okay, so that's going to be plus or minus 1, plus or minus 1/2, and plus or minus 1/4. So now I have all the possible rational roots. Now I want to find out which ones are actually roots or zeros. So we're going to go through and we're going to try these out with synthetic division to see which ones give me a remainder of 0. Now I'm going to start with positive 1. You can start with any of these, but usually for our cases, negative 1 or positive 1 is going to be a root. So let's start with positive 1 first. Let's see what happens. So I'm going to write 1, and then I'm going to use my synthetic division. I'm going to write all my coefficients of this polynomial. So 4, -9, 6, and -1. All right, so let's go through with our synthetic division. Remember, we're going to bring down this first number, multiply, and put it right here. Then add, that gives me a -5, and start all over again. So -5 times 1, and add. And then one more time, 1 times 1, and add. Hey, guess what? I get a remainder of 0. So that means this number is a factor of the original polynomial. So that means if I want to write this out in factored form, I can start by writing f of x equals, well, if 1 is a factor, or I'm sorry, 1 is a root, then x minus 1 is a factor. Now to write the other part, what's left over is going to be these coefficients, and if I divided by x, now everything's going to be 1 less power than before. So this is now 4x squared minus 5x and then plus 1. Now I've got to deal with this polynomial right here. This is still not factored. So I need to use now either my slip and slide method, or I can use my quadratic formula. Well, we're used to using slip and slide. Let's try it out and see what happens. So I'm going to use slip and slide, and I'm going to multiply this 4 by the 1. So that gives me x squared. I'm going to write, we're using slip and slide. So x squared minus 5x plus 4. And hey, guess what? I can factor this as x minus 4 and x, oops, that should be a subtract 1. 4 and 1 give me 4 if I multiply, and -4 and -1 give me -5 if I add them. Okay, but last step, since I'm doing slip and slide, I multiplied by 4, so now I need to divide by 4. Okay, so this gives me x minus 1, and this one right here, remember, you can slide the 4 out front. This is 4x minus 1. So this right here is this polynomial factored. Okay, so my final polynomial is x minus 1, and then I also have an x minus 1 here, and then 4x minus 1. Okay, so remember, our zeros are anything that make these factors 0. So my zeros are 1 for both, and 1/4. Now, 1 is a factor, or I'm sorry, 1 is a root twice. So that makes sense because we have a polynomial to the 3rd power. So we have 3 zeros, 1 twice and 1/4. So we're done. Okay, next one, we kind of separate this out. This one, again, we're going to write all of the possible rational zeros first. So we're going to take factors of 2, plus or minus 1, plus or minus 2, and we're going to divide by all the factors of the leading coefficient. Now the leading coefficient is just 1, so that means we can just stop here. Those are all the possible rational roots. So again, let's start with one of these, and let's try -1 this time. So I'm going to write -1, and we're going to try synthetic division. So let's write our coefficients, 1, -2, -1, and 2. And we're going to divide. So again, just like before, use synthetic division. You bring your 1 down, multiply, and add. Multiply, and add. Multiply, and add. Hey, guess what? I got a remainder of 0, so -1 is a root. So I can now write this as f of x equals, well, if -1 is a root or a 0, then that means x plus 1 is our factor. Then use these coefficients to write what's left. So you've got x squared minus 3x plus 2. Now, I'm going to take a look at this as a trinomial. Either we can factor it nicely with guess and check, or you got to use quadratic formula. Let's see if I can factor this using guess and check. Well, factors of 2 are 1 and 2, and if they're both negative, hey look, that gives me -3. So this is actually going to factor really nicely. We've got x plus 1, and then this is going to factor as x minus 2 and x minus 1. Now you're done. So you're going to take a look at your factors and write what your zeros are. So your zeros are -1, +2, and +1. And you're done there. If you take a look up at your possible rational roots, you'll notice that all of these numbers were from the possible. Okay, and just double check, this is an x to the third, this is a cubic, and we have 3 zeros, so that's good, we're done on that one. Okay, 2 more. We've got now an x to the third, but we've got a 5 out front, so all of our possible rational roots are plus or minus 1 all over, plus or minus 1, and plus or minus 5. Okay, so we've got some fractions. So this is going to be plus or minus 1, and then plus or minus 1/5. So that's half the problem. Then let's try some out. Let's try +1 this time. Okay, so +1, again, using our synthetic division. So writing my coefficients, -5 and -1. Okay, let's go through. So bring your 5 down. Multiply and add, multiply and add, multiply and add. All right, so we've been getting lucky. These ones have been zeros for all of them. Okay, so this one, that means now I can write my function. If 1 is a 0, then that means x minus 1 is my factor, and then write what you have left over. So 5x squared plus 6x plus 1. Okay, so this one, I'm probably going to have to do a slip and slide. You, again, could use quadratic formula, but I don't usually like to use it if I don't have to. So with this one, we're going to use slip and slide. So we're going to multiply our 5, our a, and our c value. So let's kind of do this off to the side. This is x squared plus 6x, and then plus 5. And then I can factor this right away as x plus 1, x plus 5, and then don't forget, since you multiplied by 5, now you need to divide both by 5. So this gives me, remember, slide the 5 out front, 5x plus 1, and then this just simplifies to 1, so x plus 1. Okay, so we factored this trinomial, and we already had one of the factors. So completely factored, this polynomial is x minus 1, and then x plus 1, and 5x plus 1. So again, to find your zeros, it's +1, -1, and -1/5. Just like that. All right, last one for finding possible rational roots. Okay, same steps as before. So let's list all possible first. So plus or minus 1, plus or minus 3, that's from the constant, and then divide by the factors of 3, plus or minus 1, plus or minus 3. So this is going to give me plus or minus 1, 3, or 1/3. And then let's try them out again. Let's try something other than 1. Let's try -3. Okay, so -3, let's write our coefficients, 3, 11, 5, and -3. Let's use our synthetic division, so bring the 3 down, multiply, and add, multiply, and add, multiply, and add. Okay, so I knew ahead of time that was a factor, that's why I tried that one. When you guys are trying them out, just try any. If you get a remainder, just move on to the next number. Sometimes you will have to do that. Okay, so that means if I were to write this function again, I could write x plus 3, since 3 is a 0, and -3. And then again, write your trinomial that's left. 3x squared plus 2x minus 1. And then last step, let's use our slip and slide since this is a trinomial and this number is not 1. So again, to factor this, this is going to be x plus 2x, this should be a squared. And then if I do a -1 times 3, that's -3. And let's see, if I want to factor that, that's going to be an x plus 3 and an x minus 1, because a 3 and a -1 add up to +2. Okay, so then I'm completely factored. I've got f of x equals x plus 3. Oh, you guys, I almost forgot. I multiplied everything by 3, so I have to divide everything by 3. Okay, so this leaves me x plus 1 and 3x minus 1. I almost forgot the last step of slip and slide. Okay, so now that I've done that, kind of section that off, I'm going to write x plus 1 and 3x minus 1. There we go. So that's completely factored. Last step, say that your zeros are -3, -1, and +1/3. Okay. And then last problems for 7.1, we're going to see if these are factors of the given polynomial. So what we're going to do is we're going to divide. Now you guys can use synthetic or long division, and if you get a remainder of 0, then your answer is yes, it is a factor. So for the first one, I'll do synthetic for the first and I'll do long division for the second. So this one, if I want to use synthetic, again, I need to write all my coefficients here. So that's 8, 80, and then careful, I don't have an n to the first term and I also don't have a constant. So you need to write a 0 or a placeholder for both. Then on the outside, if n plus 10 is your factor, then that means -10 is your 0. So let's go ahead and get started. Bring down the 8, multiply, and add, multiply, and add, multiply, and add. Okay, so we got a remainder of 0. What this means is n plus 10 is a factor of this original problem. So yes, n plus 10 is a factor. And that's it. As long as I can see that work, you will get the points for this problem. So then the next one, just so we can review, I'm going to do long division. So what we're going to do is write our divisor out front, so a minus 4. And then just like with regular long division, we're going to write what we're seeing if a minus 4 is a factor of. So I'm going to write everything here. A to the 4th plus 2a to the 3rd minus 29a squared plus 29a minus 29. Now I didn't need any placeholders here because I had a to each exponent, so we're good. So what I want to ask myself is, what do I need to multiply a by to get to the a to the 4th? Well, that's a to the 3rd. And then take this term and multiply by each term here. So a to the 3rd times a is a to the 4th, and a to the 3rd times -4 is -4a to the 3rd. Now don't forget, with long division, you are subtracting this. So when I subtract, this is going to give me 0. And when I subtract this, what you're really doing is adding a 4. So this is going to give me 6a to the 3rd. Now bring down -29a squared. Okay. Now we're going to do a times what gives me 6a to the 3rd. That's 6a squared. Then take this term and multiply. So that gives me 6a to the third, and it gives me negative 24a squared. Don't forget, you are subtracting. So when I subtract, that's going to give me 0. And this, if I'm adding, since it's a negative and a negative, what I really get is negative 5a squared. Okay, then what does a multiply by to get to negative 5a squared? That's a negative 5a. Take this term and multiply by each. So that's going to give me negative 5a squared, and it's going to give me positive 20a. Don't forget, you are subtracting. This 29a needs to be here so that I can combine terms. Okay, so this is going to give me 0, and this, when I subtract, it's going to give me 9a. We're almost done here. Bring down your negative 29. And I'm going to see a times what gives me 9a, that's plus 9, and then multiply. So that gives me 9a, and that gives me 9 times negative 4, that's negative 36. Don't forget, you're subtracting. And then let's see what happens here. So this gives me a 0, and then these do not give me 0 when I add these. So this is 7. And that is not 0. So the answer to this would be no, it is not a factor. We did not get a remainder of 0.